Hey guys, how are y'all doing? Excellent. So I guess I'll get started here. So you might wonder, the ascot, is it a fashion statement? No, I'm going to convince you, hopefully, with this presentation that as HTML5 developers, we are all Batman Adam West. And you know, Adam Shell, which I'm going to show you, is the Batmobile of HTML5. So this is my little tribute to Adam West, the ascot. I don't pull it off well, but this is his luxury gear. He suits up with a smoking jacket and ascot, so that's why. So let's get this started. So I kicked off an Adam Shell. My slide deck is made with Adam Shell. So I want to tell you guys why HTML5 and Node.js need a Batmobile, and I'm calling it atomic desktop power. And I gave a similar talk earlier this spring on Node WebKit, and Adam Shell is a similar technology. It's Node.js plus some sort of web display, some way to display your HTML bundled all together in a desktop application. I've been running with Adam Shell, and it's awesome. So I want to show you guys all about it. So, hi, I'm Ben Farrell. You can find me on Twitter, bfarrellforever. I'll post some links afterwards and let you know, what my source code looks like and all that jazz, so I don't have to go into it here. If the internet wasn't so slow, you could follow along on your very own computer over that IP address up in the upper right-hand corner. I'll get into how that works in a little bit. But the internet's kind of slow, so it's probably not going to work out. I was just trying it before. Anyway. So we're here as HTML5 developers. We could probably all agree HTML5 is awesome. Cool. Now, HTML5 has structure, power, and style. So when you look at an HTML document, that's where the structure lies. JavaScript has all the power. You can script anything you want. So there's some awesome power there. And CSS, as we know, that's style sheets. So structure, power, and style. Well, guess what? Batman's awesome too. I hope you agree with me, and especially the Adam West version of Batman. Batman is awesome. Batman also, like HTML5, has structure, power, and style. So I mean, Bruce Wayne's sitting there, Adam West, with the smoking jacket, and nice tailored suit. He has some style. And who goes around with bat makeup if they don't have style? And of course, fighting crime, we got some power. Structure, you can see Batman and Robin solving crimes in a very structured environment. So yeah, Batman does have power, structure, and style, just like HTML5. Now, every hero needs a good origin story. Batman's origin story is a little dark if you're not familiar with it. His parents die, and they get shot in an alley, and he turns to, I'm going to be a superhero and get vengeance on crime. But again, Adam West, 1966, it's fun. Sometimes these things are too dark, and we want to just do the Batusi, completely ignoring our really dark origin stories. Well, some might say, and maybe you don't, but I might say HTML5 has some dark origins too. Apple came in and killed Flash and Java, kinda. HTML5 is ready to get vengeance on the enterprise world. So, you might not say that, but I do. But again, we prefer to think the happier times. So we prefer to think of rainbows, unicorns, and kittens. Yeah, so happy thoughts. Now, of course, HTML5 is just a buzzword. When I say HTML5, I mean the whole modern web stack. You might even throw a backend technology in there, like the mean stack with Node.js, Express, and MongoDB. I'm just talking modern web. So, given that, HTML has a long history, spanning decades even, and it can handle itself in a fight, just like Batman. I mean, if you take a desktop framework today, like some kind of desktop runtime, it doesn't even feel like it compares to the long history of UI that HTML5 has, or HTML has. So I mean, you got lists, you got divs, you got spans. We have JS eventing, we have mouse keyboard events, even vector graphics and web fonts. So we got tons of good stuff that's been on the web for ages, and it's just itching to come into the web, the desktop world. And it has to some extent with various different technologies. But my point is, it's all good stuff, and it's there waiting for you to tap into it. And of course, in recent years, the true HTML5, we got some additional tricks. And they're kind of utility belt tricks. So they go in your utility belt. As a developer, you might not need to know they're there, but it's great tricks. So like we can play video, we can play audio, we have microphone access, we've got local storage, we can draw on a canvas, we can draw it in 3D with WebGL, we have some CSS transforms. So these are some cool tricks we can pull out of our utility belt. And I want to bring those to the desktop as well, outside of a browser. So when you think about Batman and all his friends, we have a trusty sidekick, Robin. You know, Batman can fight alone, right? I mean, he can take on a fight. Now, jQuery the same way. We can code in plain vanilla JavaScript, but sometimes it's easier just to have a trusty sidekick there hanging out with us and fighting our battles. Now, Angular and other frameworks, extra help in times of need. So you don't see Batgirl too often in the 1966 Batman, but she'll come in and she'll help out. If there's like a bunch of supervillains and there's a big battle, she'll come in and help out, just like Angular. You don't have to use Angular all the time, but it's extra help. A loyal servant, Alfred. So people know him as Bruce Wayne's butler, but guess what? He's down in the Batcave helping Batman solve crimes. He gets calls from Commissioner Gordon and says, Batman, go do this. And that's kind of like what we have with Grunt or Gulp, our task runners in our front-end tooling. So Grunt and Gulp, we can copy files, we can minify things, we can concatenate things, we can push up stuff to a deployment server. It's all happening in the background. And it doesn't get a lot of credit because it's not right there in your face in the browser. But guess what? It's a loyal servant, just like Alfred is. So riddle me this. So Batman can fight crime. He's got cool gadgets, sick dance moves, of course, and he's got tons of friends. But how does he actually solve these crimes? It's another piece to this ecosystem. And of course, that's the Bat computer. You ask it a question, get a response. How does it work? Who knows? I don't know. In this scene, actually, we have the Riddler actually made some kind of secret message with alphabet soup. So they put it in a thermos, and they actually pour it into the Bat computer. And they get a message back saying what the Riddler did and where he's at right now. That's ridiculous. But it goes to say, you know, you feed in, maybe it's a back-end web server. You feed information with a request. You get stuff out, maybe a JSON object. How does it work? We don't care. It's on the back end. Nobody knows. That sounds familiar to me. And here, it could be any back end, but I'm talking about Node.js. Now, Node.js, it offers a lot of power. HTML5 just doesn't have that power. And it's not because HTML5 is bad. It's because it's living in the browser. It has its security sandbox. You just can't reach in and look at local file system access. You can't access all these files wherever you want on the end user's computer. And of course, you all know Node.js web server. That's what people typically use it for. They use Express.js to serve up web pages, to serve up an API. That's the typical use case we have of Node.js. And then socket servers. We can do fast communication with WebSockets. Of course, robots. If you've ever seen Johnny 5, you can control like an Arduino board, blink an LED light, or even control a robot. Bluetooth. There's communication and messaging over Bluetooth. You can all do this with Node.js. And if you get into a pickle, C++ add-on capabilities. Whatever you want to do, if it doesn't exist in Node, and you can't do it in JavaScript because of the way Node works, let's add on a C++ add-on. So we got some awesome power here that you just can't do today with pure HTML5. So, and Node, or any backend really, it's perfect when you're in the Batcave, and connectivity is a sure thing. But sometimes we have to run outside. The internet might not be available. I actually work at GE, and sometimes we'll put applications into a nuclear power plant or some lockdown government facility. You can't have open internet access in here, but maybe you want some awesome power from Node.js. So those are my concerns right now. No internet sometimes. So you might be able to see where I'm kind of going with this, talking about combining these two different technologies. And this is the famous scene from the Batman 1966 version when they're sliding down the bat pole. They say atomic batteries to power, turbines to speed. They're buckling up, the Batmobile's ready to go, ready to move out. This is what they say like every episode. So we're talking Atomic desktop power, Atom Shell is the Batmobile of HTML5 because it combines all this awesome goodness. So what is Atom Shell? Let's take a step back. So let's take a step back even from Atom Shell, where we can talk about the Atom code editor. So GitHub put out a pretty nice code editor, and it's based on some specific technologies. It's based on Chromium and Node.js. And I have WebKit X'd out there because I gave this talk once before, and I said it was just WebKit plus Node.js. And it's an easy mistake to make because if you look at other technologies like Node WebKit, that's WebKit. That's WebKit plus Node.js. But the Atom team decided, let's use Chromium. And Chromium, as you might know, doesn't use WebKit behind the scenes. It uses an alternate agent called Blink. And so it becomes Blink and Chromium plus Node.js. And that gets really important because WebKit, it doesn't stay on top of things, it seems like, as much as Chromium does. Like, I just sat in the VR session today, and there are beta versions of Chrome and Firefox today that support, like, VR headsets. I don't think that's quite in the real version of Chromium yet, but even like things like the web animation API, which is very new, I tried it out in Chromium. It works. It's part of it's in our worlds right now. And take a look at web components. Like, I don't think WebKit does that yet, but works well in Chromium. So Atom, the code editor, which you can see right here, it has a lot of power behind the hood. I haven't played with the code editor too much, but it's there. It's nice. It's a nice thing. I prefer my other IDE. I like WebStorm, but you know, give Atom a try. Whoops. So under the hood, though, Atom is powered by Atom Shell, and it's the same technology. So Atom Shell is still Chromium plus Node.js. It just happens there's no code editor right there. All the HTML, JavaScript, and CSS, it's really up to you to build anything you want using this platform, this awesome platform. So, you know, just like Batgirl, Robin, Batman can all pile into the Batmobile, we can have HTML, Node.js, all our Angular friends, everybody pile into Atom Shell, and we have a sweet ride. So it's a pretty nice system. So, you know, as always, it's Chromium. It's Chrome, so load it up with your preferred stack. You know, throw Ember in there, throw CSS3 in there, throw plain vanilla JavaScript, Angular, Backbone, whatever. It's all going to work because you're essentially targeting a browser here. And the difference here is that you're not locked into one or many browsers. So how often is it that we're developing in Chrome or Firefox, and towards the end of the cycle, oh, I forgot about Safari and IE. That's not the case here. We're making a desktop application, and we're targeting one platform. It happens to be Chromium. And being that you're targeting one platform, it's super easy. You don't have to worry about anything else until you take your desktop application and bring it to the web maybe someday. So we're talking about packaging it all up and target your dev efforts for one platform. But you can also think of it this way. You know, we have to deal with many supervillains, just like Batman does. You know, the Riddler might be Opera or something, and Catwoman might be Firefox. I don't know. Somebody told me, like, when I was giving this before, like, the Joker has got to be IE. I say no. I say the Penguin is actually IE because I'm imagining IE walking around all short and fat with like squawking around. That's my impression of IE. But however you put it, there's many supervillains to deal with, and they're all the browsers you have to deal with. And when they gang up and you have to deal with all of them, it becomes a two-parter. Has the giant clam really swallowed Robin? Find out next week. Same bat time, same bat channel. Well, it's kind of like your dev timeline. You know, you're building a web application. Oh, I forgot about IE, and my dev cycle becomes a two-parter. It gets extended out. So, you know, it's really powerful that you're targeting one single platform here as a desktop application. So now so talking about this as a simple environment, targeting one browser, that's not really compelling enough. I mean, you wouldn't go to a project manager and say, I don't really want to do a website because I don't want to deal with all the browsers. Let me just make a desktop application. So there needs to be some additional power there where we say, OK, this is a compelling choice for my project, and this is why it needs to be a desktop application. So let's think about what that back computer is, what Node.js is, and how we can bring it into this ecosystem. So, whoops. Oh, where's the back computer? Yeah, so if you look at the Batmobile, they have a mobile crime computer right in the trunk. And that's just like the Atom Shell environment. You have GitHub, you have Node.js right in the trunk, so you can use it in your ecosystem. So how does it work? Well, we usually fire up Node apps via the command line. So if you're doing just a normal Node.js application, you're going to type something like node main.js, and that'll launch your application from the terminal. Well, check it out. You can do the same thing with Atom Shell applications. As an end user, you don't want to do this. You're going to click on an executable. But as a developer, you want to streamline an easy workflow. So what you're going to do is target your Atom Shell binaries in much the same way. So you target the Atom Shell executable. You tell it what app folder what all your HTML files are in your JavaScript. And you can give it some more arguments. So that's a good way for development. And it kind of works in the same way that Node.js does that you're familiar with. So let's start easy. I'm going to start with Gulp. You might use Grunt, but these are all task runners. They're tools to get us going. So let's check this out. If I were to npm install Gulp download Atom Shell, or even Grunt download Atom Shell, we get some real goodness here. So I'm downloading a task to download the binaries that are associated with Atom Shell. So that's really cool. I think it's amazing that they did this. And it's not because it's so much work to go online and download a zip file and extract it. It's that the Atom Shell team is putting a lot of effort and a lot of thought into making this a great ecosystem to develop with. So in the world where we're dealing with like Bower dependencies and NPM dependencies, and we're pulling those down, we can pull down these binaries in much the same way. We just issue a task and it pulls them down, and that's part of our workflow. So I think that's really well thought out. I'm kind of surprised it's there and surprised they put the effort into that. So thinking about how to launch our project, well, we're going to install Gulp Shell or Grunt Shell if you prefer. I've just been playing with Gulp lately, and I like it a lot. So we're going to require Gulp Shell or require Grunt Shell. And what the shell task does, it's just like you typing into a terminal, issuing a command, like maybe you're making a directory, so you could have a Gulp task, a Gulp Shell task to mkdir, and it makes a directory. Here, we're just making a shell task, and we're saying, OK, launch my Atom executable against my application folder, which happens to contain all my HTML, JavaScript, and CSS goodness. Cool. So what are we actually launching here? Well, if you look where Batman's pointing, he's pointing at the package.json file. And that's in the HTML application folder that I was just talking about. But even if you go below that, there's that binaries folder. The binaries folder is what we downloaded. That's what Atom Shell is. So if I took this screenshot actually on Linux, so if you look at binaries/atom, that's the executable you'd run. And on Windows, it would be atom.exe. On Mac, it would be kind of a different directory structure, but you can see the .so files, and those will be DLLs on Windows. I think they're dilibs on Mac. So there you have all the binaries you need to get going. And so, of course, whoops. So where's the entry point? We talked about the package.json file, and that's the package.json file. So the name and version isn't so important, but we gave our project a name. We gave it a version. But the real important bit here is that main property. And that's the entry point. So just like Commissioner Gordon would call up Batman and say, Batman, there's a crime happening. I'm going to point you to this location. We do the same thing with our entry point right here. So we say, hey, HTML, we're going to start here and start our project. So the Node.js entry point, and this is like the main.js file that I'm showing you right here. So this is a sample main.js file that Atom Shell ships for you. And it's pretty simple. What we have is up at top, we're requiring the browser window. That's a typical Node.js require. So it just gives us access to that browser window object. And yeah, down below, when the application is ready, we can make a new variable, main window, equals new browser window. We give it a width and a height. And then we say, hey, main window, let's load a URL. And that URL we're loading is just a local file that we have, and it's our application. And there's all sorts of other things you can do, but this is the simplest application you can run right here. Now, once it's loaded, it's all plain vanilla HTML, JavaScript, and CSS. So there's nothing, this is like a sample HTML application that you load up with that main.js file. So and one additional note on that main.js file, if you look at Node WebKit, the main entry point would not be something like this. The main entry point for Node WebKit would be an HTML page. So Node WebKit, you'd start with this HTML page, and then you'd kind of launch your application. What I really like about having this as my main entry point is I can start with many windows at the same time. I can start with no windows and wait for some like keyboard input to happen. I have a lot more control right up front with Atom Shell because there's that JavaScript entry point as opposed to a HTML page entry point. So yeah, like I was saying, once it's loaded, it's all plain vanilla HTML, JavaScript, and CSS. You might notice some funny business right here because it doesn't have to be plain HTML. It could be a sparkly new tech like Polymer. I've been playing a lot with Polymer lately. I was kind of nervous about making something with Polymer in case I had to run it in Internet Explorer. But again, I have the latest Chromium here, and I can just make a Polymer application and not really worry about other browsers. So I get a lot more brave when I have to target something. So I'm psyched about that. It's even if you're not making a production application, it's just fun to play with the latest technology and have to worry about this stuff. So we have pure HTML, JavaScript, and CSS, but no JS call. It wants into your HTML5, so let's pick up that phone. Or Alfred can do it for us. So I'm running this slide deck right now. I wrote the kind of how it plays out. So here's my load deck functionality. And you might notice something funny here that you don't see in normal JavaScript that you'd run in the browser. And that's the file system call that you'd normally see on Node. It's right there, right inside my just my JavaScript that I run inside kind of the browser window. And that's great. Normally I could do this with an AJAX call. And I still can, but I kind of got lazy. I said, well, I have local file system access. I can read files synchronously, so it'll pause execution while it's loading the files and parsing them out. And I can do it over 7 or 8 files because I have my slide deck here divided into chapters. So, you know, that's awesome. Local file system access right in line here. I think that's awesome. But, you know, going beyond simple file I/O, of course, Node.js is known for serving web pages. And if we had awesome internet here, you could go to that URL in the right-hand corner. And how that actually is working is I'm running a web server right now in my Atom Shell slide deck executable here. And that web server does not express JS. It's a simpler file server. And it's serving files over the IP on that specific port number. So don't forget that you could have a full-blown web server right here in your application. And you know, if you think about this a little, maybe you have a DevOps team that's not familiar with Node.js. Well, how do they restart, log, do all that type of stuff without knowing the command line stuff, without knowing how Node.js works? Well, you could build an entire like user interface with an executable they'd launch to start your web server. That's pretty cool. And they can shut down your web server with a click of like a bootstrap button, or look at a log with, they could look at your log files with some D3 stuff right there inside the instance. So I think that's pretty cool. And you know, just to point out, Node.js stuff, it's right, like even something simple as the process.argv object, we all know and love with Node.js if you're familiar with it, but it's right there in Atom Shell too. And if you're not familiar with it, like you could pass in a series of arguments, and you know, when you pass in those series of arguments to Node.js, you can query that argv object, and it'll process all your incoming arguments. So with this slide deck, for example, it's not necessarily full screen without a title bar, but I said, okay, my argument here is going to be that I want to launch it, you know, full screen without a title bar. I pass that argument in, and here it is. So you can do a lot of things as you launch things with the use of arguments. And the other thing about doing web development is we don't want to think too hard. We need some way to debug things. So, and this is another thing about Node WebKit, kind of why I gravitated towards Atom Shell, is because with Node WebKit, I'm pretty sure it still happens that I could right-click and then I could load up the debugger tools. I don't like that. It's not very, it doesn't feel very secure if anybody can just load up my debugger tools right here. So with Atom Shell, of course, it's all programmatic. So you say, you target my window, open up the dev tools, and I tied that to my keyboard command, which is D right here. And all of a sudden, I have a console with no errors in it. I can start looking at my entire application structure. And like I said, we have the shadow DOM right here. Awesome. So I can go in and start taking a look and start highlighting elements and changing things around if I want. Let's change one thing around. Turn that off and oops. Come on. There we go. Well, it loses some styling. But yeah, full-blown web debugger right here, controlled programmatically. So awesome. So what if I wanted to make another window? Well, I just create another variable, create a new browser window, pass in the width and the height, and I could have it up at the same time. So in my slide deck here, I like to measure how long I spend on each slide so I can perfect my slide deck for you guys. And I have a little D3, it's kind of crappy, but it's a D3 visualization about how things are going. So I'm going to load up my stats window. And OK, this is how long I've spent on each slide. It looks really bad because I haven't spent too much time on it. But the important bit is my window in the background is a full screen window. I just launched another window on top of that. No problem having a secondary window. And I can just close that. So when you call up a new browser window in Atom Shell, you can give it an XY position, you can give it a width, you can give it a height, you can go full screen, you can say, OK, I always want to be on top of all the other windows. There's tons of options. You can go like framed or frameless. So I'm going frameless here, no title bar. I can skip the taskbar. So if I mouse down below, like it would not be in the title bar. Another cool thing is web security. So I was trying some experimentation with Atom Shell, and I loaded up like something like Craigslist just in Atom Shell in the browser, created a desktop application that was just Craigslist wrapped in it, and I tried to inject script tags in there. And you might know that if you try to access script tags over the file protocol versus HTTP protocol, there's crazy web security errors. Well, you can just turn that off with a web security flag, and you're good to go. So no complaints there. So as we're getting into more how Atom Shell works, there's some nomenclature, and it's kind of confusing. If you go to the documentation around Atom Shell, I kind of have to keep referring back to it because they call the browser the Node.js side, so the actual application environment where you program in Node, that's the browser. And then the web page, that's the HTML5 side. So if you're doing just HTML type stuff, they call that the web page. So terminology done. So as you might imagine, Chromium to Node communication, your Node instance to what's on your HTML content, communication between those might be a little bit of a ticking time bomb because it's not a standard thing. It's just something they bridge together, and it works out. But you have to know how it works out. And I ran into a few issues when I was doing this. The first concept they have when this bridge is global variables. So you set up a global variable in Node just by saying you'd be using the global variable, and it's key value pair. So you can set the property whatever var you want to call it. And then you'd think you might want to get that on the HTML side by saying just global and then the property name. But no, you have to require the remote package and then do remote.getGlobal and then myvar. Functions can cause bad stuff to happen. So without doing any research, I thought, well, I could create a messaging kind of, I could have some event listeners if I use the global object and I just assigned a function to it. No, it causes like Stack Overflow errors and bad things to happen, so I had to lay off that rather quickly. But there is inter-process communication. So from the web page, you have to, and that's the HTML instance there in the browser. You require the IPC object, which is the inter-process communication object, and you can do IPC send, and then the event you have named, and then an argument. And then you can receive that using the same thing, IPC on named event, and then grabbing the function. So cool. It's different, though, if you're coming from the Node.js land, because you actually have to target window.webContent. So you have a variable that contains your window, and then it has a web contents object, and from there you can send the message. Now, IPC can be a little bit of a ticking time bomb because IPC, instead of send, they have a send sync function, but they recommend you don't use this. So it's kind of bad if you try to use this without knowing what you're doing because, so when I originally tried to use this, I was using it as it was loading up my web page, and since it's synchronous, it locks up everything in the browser as it's going on until it finishes, and it caused all my images not to load. So kind of bad news there. You should be very careful when using send sync, but it's there for you to use. So packaging up your application, there's really not much to packaging up your application. Oops. So I'm going to load up my desktop. And then here's what you would get if you actually downloaded an uncompressed Atom shell. I'm going to run the executable. And guess what? They make it so easy. You just drag your files into there to run your application. So right out of the gate, this is the easy way they offer you to package up your application. But inside here, we have resources folder, then we have a default application folder. So packaging up your application file folder, or your application, is as simple as dropping these files in. So, and that's really cool. There's not really much to it. There is another way to package them up, which is called ASAR. And it's kind of tarballing the thing. It doesn't really compress it, but it makes it more secure, so you can't go in and look at these source files. It doesn't really offer anything more than security. It kind of complicates things when you try to maybe load up local file resources because of the sandbox. But yeah, packaging up an application is super easy. So we have all this power with Node. But sometimes we need a little more power, and we have to be a little unnatural about things, which means maybe getting into C++. So let's talk about tweaking the Bat computer. We can get more power and speed by making C++ add-ons. We're probably not all familiar with C++, and I'm not really that either. But I was playing around with it, and it's kind of fun getting into it. So Node.js is not 1.0 yet. It changes over time. So just to give you a little history lesson, prior to Node 08, there was a compiler called, it was a build tool called Node.waf. Ignore that completely, it's not current anymore. Now we use Node.jip. Both are Python-based build tools. So it all starts with the binding.jip file. So when you go to Node.jip configure this thing, or just when you do an npm install, it'll cause any C++, it'll hit the binding.jip file and cause your C++ to compile and all scaffold out. Binding.jip file is real easy. So we have a target name, which is our module name. And then we have some C++ source code. And that's pretty much it. That's all you need with a binding.jip file. And so what it creates in that structure is it uses that binding.jip file and creates a bunch of stuff for you. I don't know the full extent of what all this stuff is, but on Windows, we're talking about Visual Studio files. On OS X, we're talking about Xcode files. And that means you have to have these tools installed. But the important thing right here is this hello-world.node file. That's our actual add-on. That's what's important to us. So when we go in and do the JavaScript side of this thing, we have, this could be a one-line JavaScript add-on. So we just include that, and our functionality for our hello world thing is right there. And that's all we need. But we could get a little more in depth. We could make our add-ons a little smarter by adding a little JavaScript. We could add on some other functions in JavaScript on top of that, and I'll put it in the same JavaScript file and really get some nice logic that we can easily edit in JS, where we put the bulk of our hard work in the C++. So that's kind of how it all gets scaffolded out. How do we make this how do we actually write the code? So it's a little complicated because Node is changing. So Node 11 versus Node 10. So Node 10 is what we all use today if we're just doing normal Node stuff. Node 11 is the new upcoming thing, and they changed their API a little bit. So you have that new isolate keyword, and there's slightly different ways of writing the same thing. So if you write something in Node 10, it's not going to be compatible for Node 11, and vice versa. So an Atom shell actually uses 0.11 32-bit. So that's a problem. And it's a reason why a lot of packages you might find on the web that are fairly complicated might not work in Atom Shell today. But luckily, some smart person created native abstractions for Node. And basically, it wraps up all that functionality, creates a wrapper around all those functions, and just allows you to create some better ways to handle the changeover from 0.10 to 0.11. So if you write your code like this using this native abstraction layer, it'll all work across like 0.8 through 0.12 upcoming in Node. So that means it can work right in Atom Shell. So that's really good. And then, of course, if you're familiar with Node, no npm install. What we're using here is an apm install instead. So apm is the Atom package manager, and apm kind of forces things to go 32-bit compilation for Atom Shell, and it forces 0.11, and it wraps it on some additional headers for C++. So it kind of magically wraps everything, and it wraps npm install and does it in such a way that it works with Atom Shell. So cool. So I created some examples. I showed you guys the Hello World example. Here it is working as something that'll work in 0.10 or 0.11. So all it is I'm saying, oh, I'm going to create a new function here. It's called hello. And the method is, I called it method. I shouldn't have called it method. I should have called it hello world. But it's tied to this argument right here. So here I'm just creating a function called hello. And when I call it, whoops, it gives me an alert and says back world. So it's pretty simple functionality. We can get a little more complicated. So in this add-on, I created something that creates random coordinates in 2D or 3D space, passes it back as a JavaScript object. So we can move the box in 2D or 3D. And again, I'm not doing this in JavaScript, though I could. It would be super easy, well, easier than making a Node plugin or a Node add-on. But I'm getting this information back from my C++ code. Now, why would you do this if I'm just moving around a box? Well, there's the speed aspect. So I'm going to count to 1 billion with JavaScript. And this is all part of my sample add-on here. So with JavaScript, it's going to take 2.6 seconds. I'm going to do the same thing with a Node.js add-on as part of the same thing, as part of the same module. Do it with C++. Finished in 0.4 seconds. So you see, like, if we do stuff in C++, you get a huge speed boost. And you might need that. So we're making a better Batmobile with all our C++ goodness and our add-ons, but so what, really? Because sometimes you really need it. And I hope this demo works. So the OpenCV just released 1.0, and OpenCV is a computer visualization library. It's originally written in C++, but some smart person named Peter Braden decided to port it all to Node. So we can do cool things with computer visualization and face detection and all sorts of good stuff right in Node. And he actually got a fork from somebody to force it to use the native abstractions. So it now works in Node 08, 09, 010, 011, and it works with an Atom Shell. So let's try it out. And it's OK. It does something weird when you first start it up, so I'm going to start it up again. There we go. So it's a little dark in this room. But you can see it's kind of tracking my face. And what it's doing right here is I'm giving Node.js, I'm taking the camera information, and I'm telling OpenCV to draw a circle around my face. It knows how to recognize faces. And then all I'm doing is I'm taking that binary blob of data, and I'm just throwing it on an image tag right in Atom Shell, right on the HTML page. So there's some really cool stuff you can do here. And in terms of other solutions, we have Node WebKit. I've mentioned Node WebKit all along, and I was really excited about using it before, and I'm still excited about using it. But I'm really more excited about using Atom Shell. And I mentioned a few reasons why. But anybody who uses Node WebKit, you're pretty much doing the same stuff, the same awesome stuff. I just prefer Atom Shell, like I said. Now, Adobe Brackets. Adobe Brackets kind of got the shaft. So they created the same thing that Git created with Atom a while before they did that. And It's the same thing. It's like a Chromium instance plus Node.js. It's the same thing. But guess what? Brackets didn't make it easy for you to download, extract it, and run. They make you compile the entire thing in C++. And that makes the bar kind of high for your average user. On the other hand, Atom Shell, they give you a nice download. They make it easy for you to drag and drop your application in. So developer joy is huge, and Adobe just didn't do it with brackets. And actually, one additional point on this is Atom Shell makes it a point to say Chromium is already compiled as a binary for you. So when you download Atom Shell, it's already all compiled. You have that Chromium library. It's all done for you, and they make a big point of saying that. So again, developer joy. So anyway, we're all just happy to be working together. Even if multiple solutions come from different competitors, we can work with our enemies or we can work with our friends. We just like making awesome stuff. So, let's all celebrate HTML5. We'll make cool apps with Node.js plus WebKit or Chromium. Either way, it's really fun. So let me see how much time. Oh, I think I'm good on time. So yeah, thanks for coming. Here's a few links. I'm going to write up a blog post later just to throw out these links at you. The first one is my site, so if you want to just see these links on my site later, go there. Atom Shell, you can go to GitHub /Atom Shell to see to download and play around. NAN, if you want to create your own C++ libraries, go ahead and do that. That's where you'd npm install it from. OpenCV, this is huge. I mean, it's just such an amazing project. So go here on GitHub to get OpenCV. And then I have a little write-up because installing OpenCV in Windows is a little difficult. But I wrote up something on there. And then I have my Node example add-ons, my Hello World application, my counting application, my random coordinates thing. I have the sample code right up there and generic add-on. And this entire presentation, the source code from it, it's built in Polymer, built in Atom Shell. It's all up on my website or GitHub under Atomic Desktop Power. And I guess last slide, GE Software is hiring. I work for GE, so I can pass out business cards after this. But we're hiring software developers, front end, back end, whatever. Anyway, I think that's about time. I think so. Any questions or anything? Yeah, you. Your mom? So let me exit out of this real quick. I actually made an application for my wife, who is definitely not a developer. And there's not really any magic to it. I made her a time tracking tool called Workinit. So what she'd do is, I just passed her the zip, and she runs it just by using the atom.exe file. I would obviously redo the icon and redo the name of the application, but you just start it up via the application. So that doesn't really answer your question, though. You're saying, how do we go about installing it? And they don't really offer you a way. It's more, I think there's like third-party installer tools you can use, package it up that way. I mean, way back when I was in CD-ROM developer days, we would make director applications, and you package them up as an MSI on Windows, and you could. There's third-party applications that do that. I don't really get into them. I'm just in favor of let's zip up the whole thing, have an end user uncompress it, and just run the executable. So. There's many ways of doing it. Not really related to Atom, though. Yeah? No, you know what? I wanted to get into Polymer, and so I was making web components. And so the structure, I'll actually show you the structure a little bit. So here we are on WebStorm, and the actual slide that you see is a web component. So the slide keeps getting refreshed over and over again when I have new content. And the slide is hosted by the presentation component. And all my slides are basically just JSON. So here's some text. Here's the background of the slide. So it all gets smartly loaded in, just as web components. Anyone else? Yeah. Either one. How big is the whole thing? Good question. Yeah, I never remember, honestly. So let's take the application I built for my wife, because that doesn't have, or actually I'll just take this, what they ship as a default thing where it says drop your application here. So it's 70.5 megs. And you know, that's kind of to be expected. That's kind of on par with what Node WebKit gives you. It's not compressed in any way, shape, or form, but there it is. You?
So this may not be relevant to the stuff that you're doing.
That's fine.
I don't get to talk to many people who are doing this and stuff.
Uh-huh. Yeah, and I just started, so yeah.
So are you guys, that might have been my question.
Uh-huh.
So the core maintainers, there's always been this conversation about calls from JavaScript to see how it's being really expensive.
Mm-hmm.
Have you guys on your team built anything that has a lot of operations kind of, like have you seen any issues, or are you building mostly like desktop?
No, so I'll tell you this, like, I want to do this stuff at GE, we're just not there yet. There's a lot of applications for it. So I'm doing all this stuff on the side. So I'm building simple things, just like what I showed you here. The first thing I ever built in Node.js as an add-on was to work with 3D sensing cameras. So there's a framework called, it's not OpenCV, I'm blanking now, but it's to deal with depth information and skeleton tracking and all that. So I ended up wrapping that in Node.js as a C++ add-on, and that was my first, like, I'm just going in guns blazing. I don't know what I'm doing, but I got it done. So right with that application, I had to like start up a separate thread to keep everything running. I don't know the answer to your question, though, about how expensive the JavaScript bridge is. And you know, it might have changed because the way the JavaScript bridge is going, they added that new isolate keyword, and you know, it might be more efficient. Maybe that's why they changed it. I don't know. Yeah. Uh-huh. Well, Atom is the primary one. No, I saw a list before. No, I'm not gonna. I'm not gonna look it up online with all you guys standing here. I know I saw a list before. There's a few. They're not. They didn't. I don't remember them as being very compelling. It's all like kind of let's play around with it and see what we can do. Atom Shell right now, I think it keeps like incrementing. So like I did this presentation a couple months back, and it was like the 0.13 version. Now they released 0.16. So they keep going. They keep adding new features. So I think it's gonna capture a lot of developer attention, and people are going to start building cool things with it. Mm-hmm. Hi, could you ask that again? Oh, for a mobile app? So this isn't mobile in the truest sense. I mentioned like running outside where there's no internet connectivity. It's not mobile. It's a desktop application, but I'm kind of saying, yeah, we have offline capabilities because we don't have to go out to a backend and retrieve all this stuff. So I can't run this on my phone, unfortunately. But competitor-wise, I feel like you can get a lot of, with like PhoneGap and similar things, like you can run HTML applications on PhoneGap. And I know that I'm pretty sure they have like a C++ plugin base that you can hook into. So the ecosystem is a lot like this, and that's pretty exciting too. Yeah, you the black shirt.
2 parts. First of all, I'll help answer that, which is that I use Node WebKit to understand my questions. So the numerous, like what you see is the major benefits of Atom versus WebKit. Other thing is our app is a single code base, and it's both Cordova and Node WebKit. Desktop and for mobile. So it's very possible.
The use cases, basically, it's just how you want to approach an app. My favorite thing about Atom Shell has to be that JavaScript entry point versus the HTML entry point. Is that still the case?
Yeah.
Okay. So there's that, and I think I was having problems. Yeah, I mean, I was having a conversation with my friend Rachel Neighbors, who's way big into web animation. And the web animation API, I was just trying that out in Atom Shell, and it worked right away. And I was like, oh, yeah, this isn't WebKit. This is Chromium. So I feel like Chromium is going to have a lot faster clip developing new features as Chrome does. So I feel like that's the biggest thing, I think. Yeah. Anyway, yeah, you.
I think Node WebKit says it's built with Chromium as well.
Okay.
And there's also a page that's pretty easy to find that was put out by Adam Shell.
Okay.
Comparing them.
Oh, yeah. That's actually easy to find. So that's actually what kind of steered me towards doing stuff in Adam Shell. So they have a documentation page. And then, let's see. Technical differences. So, and like, yeah, so they have the build system, I guess. The multi-context stuff, I wasn't sure if I completely understood. So they advertise that Adam Shell doesn't introduce a new JavaScript context in web pages. So it seems like if I understand that right, it's sharing the JavaScript context among all your different pages and yeah. So yeah, an entry of application, like I said, that's big to me. Anyway, yeah, all right. Thanks for coming, I guess. Talk to me after if you want anything. Oh, it's ASAR. Yeah, I think it's tar. It's a tarball, but they even advertise. They say like, there's no compression here. It doesn't compress anything. It just makes them more secure. Yeah. And they warned you against like, if you make any external calls out to other files on your system, it's not going to work. It's sandboxed.